Hello, everyone. Thank you so much for the introduction, Artie. I am a product manager at NVIDIA, and I will be talking today about Omniverse Replicator, which is a synthetic data generation tool in order for you to augment or just create from scratch data sets. So without further ado, let's get started. I am going to share my screen. You should be seeing my screen right now. If you're not seeing my screen, please someone pop up. Otherwise, I will assume you're seeing it. Okay, awesome. Yeah, so as RT said, today we're going to be talking about leveraging synthetic data to train perception models using NVIDIA Omniverse Replicator. I specifically say perception models because today we are going to be talking about RGB, depth, or potentially other sensors that are used for perception. For use cases such as object detection, segmentation, or for instance, in LiDAR, that could be used in autonomous vehicles, for instance. The reason I became familiar with this topic is because I was a solution architect / data scientist supporting customers on utilizing deep learning in the edge. And I saw countless of projects that were stalled due to the lack of data or due bad data or simply because of how long it took to get good data. Projects would start, we would have to decide on the camera, the type of network, who we were going to collect data with. Then finally, we would get that data and we would realize that it didn't meet some of our performance metrics. And what do you do then, right? You go back, regather data, or maybe the project is over. However, there is a really easy way of avoiding this by using synthetic data that enables you to then troubleshoot and test things out before you even have to develop. So let's go ahead and get started. First, we'll talk about what is even synthetic data. Synthetic data in the way that I will be speaking today is data that is generated from these digital worlds that you can create using some graphics tools. And from there, you're able to get realistic data that looks like the one in the picture. So here is a warehouse generated in Omniverse. And here you can see all of the data that we are able to get from that one scene. We are able to get semantic segmentation, instant segmentation, depth, and bounding boxes, 3D bounding boxes, and so on. This, in conjunction with real data, can lead to awesome AI models. And even without, you can at least bootstrap your applications. Omniverse is a platform that is meant to be used in multiple industries. And with that, also the synthetic data that you can get out of Omniverse can be used. So for instance, one project that I worked on was on utilizing BIM files, which are construction files that a company like Trimble has before even constructing anything.
Nyla, I'm very sorry to interrupt. It seems like your slides are not in presentation mode, and they're also not moving further along. Just wanted to give you a heads up.
Oh, that's interesting. So I've been presenting for a while with the slides, but I will maybe if I share my whole screen. Okay, now you see yourself in infinity mode, and now you should see this.
Perfect.
Are you able to see?
Yes.
Can you see that?
Yes, perfect. Thank you.
Okay. Yeah, so just so that you know what I was talking about, this is the warehouse that I was speaking about. This is semantic segmentation, instant segmentation, and so on. But this is the data that you could get out of Omniverse Replicator. And I was talking about the industry. So there are multiple industries in which synthetic data is useful, but I was speaking in particular about the architecture and engineering side. Based on a project where we got these raw BIM files from construction Then with Replicator, we modify them a bit, and then we were able to use that data to train a perception algorithm to identify doors for spot. You can read more about that in blogs, but overall, this can be used in multiple industries. One thing that I want to emphasize is how it is traditionally done to train a deep neural network, because this differs fundamentally from training with synthetic data. So training with real data has a large amount of time in which it is spent collecting data, annotating it, then converting it to the right format, and then training. This process of collecting data and annotation is time consuming. But on top of that, it might not be the right data that you want. And in cases like segmentation, it is extremely time consuming. And don't even get me started when we're talking about segmented LiDAR point clouds. That would not be easily done. Additionally, even if you're able to gather that data and pay for a labeling, you might have issues with lacking long tail anomalies. For instance, you're unable to detect deers in a road, which would be very bad for an autonomous vehicles. You cannot have non-visual sensors. So for instance, as I said, labeling for a LiDAR is very hard, and radar would also come with velocities, would also be very difficult. Then we have occlusions and so on. So for these challenges, it's just simply very hard or impossible to get real data. And there are other applications in which case you're not really sure how to get that real data for. That would be for 6 degrees of freedom here. On the left, we have a robot whose perception was trained using entirely synthetic data. And it's learned to detect this piece, and then it uses a combination of control algorithms to effectively place it in the right position. And the other side, we have reinforcement learning, in which case it's also impossible to get real data for. And then, if we are talking about how expensive things can be, we will have a problem with things that require constant labeling. For instance, grocery stores constantly get new packages, constantly get new products, and labeling that continuously would be very challenging. So Replicator, what it is a highly extensible framework built on top of the Omniverse platform that enables physically accurate 3D synthetic data generation to accelerate the performance of AI perception networks. So we are creating a framework on top of which you can build whatever you want to generate synthetic data. And you'll be able to bootstrap your AI applications. And I'm particularly excited about bootstrapping because it's so cool that you can now be like, I have an idea. I don't know if it's gonna work. Let's just generate some data quickly, test it out, and if it works, I can ask for a larger investment and get real data labeled to like double check, right? So that to me is very exciting, and that also could lead to more developments in 3D deep learning, which has been primarily stalled due to lack of data. So this is very, very excited about potentially using 3D virtual worlds to train synthetic, to generate synthetic data to then train DNNs. Okay, but so I've been talking all great things, why you need synthetic data. However, things are all not that rosy. You need to reframe the way that you train DNNs if you're gonna use synthetic data. So the way that it would work is you ingest 3D assets. You don't have any content. NVIDIA provides you with a couple of assets for you to get started. But on top of that, you can go ahead and buy 3D assets in multiple platforms, And then once you bring them into the Replicator universe, you can use the domain randomizers, which randomize the scene and create a data set. And then with that data set, you can train an AI model. But here is where it gets interesting. With real data, you generate your data, you have your data set, and that's it. It's fixed. Maybe you do a couple of augmentations, but that's it. With synthetic data, you evaluate, and if the model doesn't perform, you regenerate. And sometimes this has shocked people. I was working with Shitej, who did a blog on door detection. And the first time we ran this model with synthetic data, it gave 10% accuracy. Then we tweaked it and we generated a new data set that looked very realistic. And then we got 60%. And then we utilized a couple of other techniques and we got all the way up to 85%. So I just want to say those numbers so that you understand this is a very iterative process, but it is really awesome the fact that you don't really need to use real data for some tasks. For other tasks, you will for sure need some real data. But it is really awesome that you can get started with it. Okay, so I said you do some randomizations. What do I mean and why do we need that? So you might be thinking, Nyla, those 3D worlds are great for video games, but they don't really look realistic enough. And you're right. There is this thing called the appearance gap, which is pixel level differences due to object details and materials with the real world. And there is this other thing called the content gap, which is no matter how many hours you spend creating a synthetic world, you're never going to have the variety of the real world. Those are two gaps that we have, and those are two gaps that make it so that the network sometimes don't perform with synthetic data. But there is a way of addressing that, and that is with domain randomization. So with domain randomization, you randomize the synthetic world so much, so you randomize, for instance, the pose of an object, and on the other side, the lighting conditions, and you generate a very large distribution, and the reality, and that very wide distribution, that very wide distribution encapsulates the reality. And with that, you're able to get a real performance DNN. On top of that, what we've done to address the other gaps, the appearance gap, is we've created high fidelity 3D assets, physically based rendering and materials. This is particularly important for synthetic data with light. So sometimes things don't need to be very physically accurate in terms of falls and things like that, but reflections matter a lot for the network to transfer. And then on top of the appearance gap, for the content gap, what we've done is we've given you access to a larger pool of assets from NVIDIA. But on top of that, Omniverse is designed to bring in assets from other platforms. So that will be very helpful to you. Here is an example where we trained PathNet, which detects lanes with synthetic data. I'm going to skip this due to time. Also for manipulation in reinforcement learning. And then this is the project I spoke about, which is utilizing synthetic LiDAR point clouds to train a DNN. Again, there is a tag on this topic. It's at the end of this talk, so you can go ahead and check it out later on. But with that in mind, let's jump in and talk about what does Omniverse Replicator provide to you. So Omniverse Replicator is built on top of Omniverse. And why is Omniverse useful to you? So Omniverse is useful to you because it's built on top of open standards. USB is becoming the standard in the graphics world, which means that there are more and more 3D assets coming into it. So that would mean that you would have to invest less time making content, or you can just pull in content from other tools. It's built on an NVIDIA MDL, which is a material library, and we provide you with multiple materials off the shelf. It also uses physics, which is our physics library, and the way that you interact with it is only in Python. So this should simplify a lot what you are building. And we've targeted heavily the machine learning engineers such that we bridge the gap between graphics and machine learning such that you can leverage the best of machine learning, the best of graphics without needing to know that much graphics. We give you previews of the AOVs, which are arbitrary output variables, which basically just means ground truth. We give you a graph-based way of implementing functions with Replicator. And on top of that, we're able to scale across multiple GPUs to generate a lot of data. So that's why Omniverse is the right platform for Replicator. Replicator is built on top of these characteristics, which is physically based. So we have very realistic materials with reflections. We make it so that it has deterministic behavior. It is scalable. You have access to large pieces of content. It's programmable. As I said, it works with Python, and it's very easy for you to get ground truth data. It's modular, and it's open, built on top of open standards. So what do we provide you with Replicator? We provide you a randomizer. So as you see here, the randomizers here are moving the poses of objects everywhere in a plane. So that is one of the randomizers, but there are many more that you can use. And what this will do is immediately give you tons of variety in your data sets. Below that, we have omnisynthetic data. Omnisynthetic data is the lower level API, which basically gives you control over the renderer to give you access to the AOVs. And the arbitrary output variables, basically I would characterize them as just a ground truth. Those AOVs are taken in by the annotator, so this is what you have immediate access to. And with those annotators, you'll be able to write down the data like the semantic segmentation or the bounding boxes. So as you can see here, you are immediately getting the data. Oh, if anyone is thinking, okay, great, Nyla, you're getting all of these images that are labeled by how do you even get the first label? Well, the thing is, with synthetic data, you only label once. So I only labeled TJ, like the character here, once. And then as many frames as I generate, it will already be labeled. So all of these frames come for one time where you created the asset and you gave it a label. Okay, so that is annotators. The types of annotators that we give you within Replicator are RGB, normals, motion vectors, distance from the camera or the image plane, instant segmentation, and so on. I'm particularly excited by what will happen with the 3D deep learning field. I really think it's been blocked because of lack of data. So I'm excited to hear what people are working on here. But you can build your custom annotator. And once you build, you got the data that you want, you need to write it. And Replicator provides you with a custom writer such that you can write it in your own format. These are the tools. Just to summarize, we have scene generation with materials, background light, the ground truth, which is the annotators, which give you the data, and then the writers. Very quickly, the Replicator API is very easy to use. You download Omniverse Launcher, then you can simply write import omnireplicator.car as replicator. You create a sphere. Then with that sphere created, you can use modify pose with a uniform distribution. You can change the color with the randomizer color function with, again, uniform distribution here. And you can basically build in from that. You can add physics there with very simple functions. And then you can get other USBs from other people to get the assets and tables, for instance, and create a scene that's much more complex, such as this one, but with very little amount of code. And just to summarize, the last piece that you would need is the writer. So you tell it to write the data, which in this case will give you like a NumPy array or a PNG, and you would get that data set. Awesome. So how do you get started? There are tutorials that you can go ahead and read. There is a landing page which has blogs. There is a code forum, which we recommend for you to ask questions. And there is the Omniverse documentation. Plus, here are multiple tags on synthetic data generation. And I was 1 minute over, but I think we're ready for the Q&A.
Amazing. Thank you so much, Nyla. Okay, I was getting that infinite loop, but thank you so much. That was a very exciting talk on synthetic data and the technology that you've built. So to start off with one question, and audience members, please feel free to add more as you think of them throughout this Q&A session. But one question is, when a new team comes to you with a different use case, what are use cases or applications that are a very good fit for Omniverse versus things that are maybe not a good fit? So how do you assess, when would this be most applicable for a team that's considering using it?
Yeah, I think that would depend on the team and what they are trying to accomplish. So we know that there are certain applications that work perfectly with synthetic data, like for instance, object detection and segmentation train really well. Of course, depending on how many classes you want. But then it also depends, does the team, how much custom content does the team need? And in that case, is that custom content in some kind of 3D partner? So for instance, there are multiple websites that sell 3D content that you can go and download. And if most of your content is there, then it will be much quicker. If not, we have to assess whether you need to either make that content in-house or go through a partner and then get content from that way. But once you have that content and you have a machine learning engineer, I think we've seen awesome results for object detection, segmentation, 6 degrees of freedom, and like with LiDAR, we got pretty good results too. So I think these areas are still very fresh in that we are still experimenting with its limits, but the results are very encouraging here. And it does depend on the team and like the extent of how difficult the use case is.
Makes sense. No, I started very high level, and we do have more granular questions coming from the audience, and actually they all poured all at once, so I'll try to sort through. But I guess another sort of higher level, and then people have more specific questions around what you support. But do you support, tabular data as opposed to video or audio, more natural data?
So I think there is a team within NVIDIA that does tabular data, but my team in particular is focused strictly on perception data.
Got it. And in terms of even just images, do you have support for generating non-rigid or organic objects as part of the tool?
So this is the beauty of Omniverse. We have a whole physics team that also works with soft body physics. So that is something that you definitely can use as your assets within Omniverse.
Amazing. Another sort of more details type thing. Is it possible to change sort of the camera, weather conditions, all of those aspects when you're trying to iterate on the images that you're trying to generate?
Yes, the camera can move around. You can also have different camera parameters that you want to have within your camera. You can also have multiple cameras producing data concurrently. With regard to weather conditions, you can change time of day very easily. Weather conditions becomes a little more tricky, but you should be able to do some changes there.
Got it. Thank you. Then we have two questions around photorealism, which is, how close to reality or photorealism do you get? And in general, what has been the importance of photorealism within synthetic data?
Yeah, that's a great question. And I answer that question with saying, what is the objective of producing this synthetic data? And the objective of producing this synthetic data is to create a network that learns characteristics that are transferable to reality. And I emphasize that because sometimes that might mean that you might do crazy textures because you don't want the deep neural network to learn the textures. You want it to learn the shapes and the dimensions of the shapes. And if you generate a synthetic world with crazy textures, you will force the DNA to learn patterns that are not textures. And this is actually really interesting because there was research published, I forget who, but it showed that especially CNNs are really good texture learners. And you might not want to learn textures. You definitely want to learn like the shapes or like potentially the deformability and things like that, and that you wouldn't get to learn if you just learn texture. So creating a very fake looking world, quote unquote, by different textures, but realistic lighting and reflections and shapes might be the way to go. So that's why I'm very careful when we speak about photorealism, because you do need proper lighting, but you might need to trick the network to not learn certain things.
That makes sense. That is a very good point that I, at least personally, have not considered, where when you think of synthetic data, you immediately consider what's that gap between the synthetic data and the real world data. But your networks do pick up, like, for example, in the healthcare setting, a lot of times, you have data sets from different hospitals. They might just pick up on the fact of, like, this data set is from this hospital instead of like actual characteristics. So eliminating the variables in terms of what your model can pick up on is very interesting.
Yeah, like sometimes networks will, like there was this husky wolf data set that turned out that the data set had only learned to detect the snow. For like, if a husky was in the snow, it was a wolf.
Makes
so
sense.
These are the things that, like, even with real data we face, right? Like the network would learn things that you might not want it to learn. So like making sure that you choose the things that are that would transfer to reality and would represent your real data set are very important. And as much as I'm in favor of reducing as much as we can real data, I do think you need to have a good test set at the end to make sure that you're verifying that your DNNs are working well.
Amazing. Makes sense. Thank you so much, Nyla. That was very, very informative.